Welcome, everybody. I'm Jay Egg with NY-GEO. I'm the moderator of this session. Refrigerants, they are a-changin'. We are going to have a wonderful session with a lot of information. I had the privilege of being the A2L committee chairman for the Uniform Mechanical Code during COVID, and oh my goodness, I left that cloud of smoke as fast as I could. And then John Shavako asked me to moderate this session. And I have learned a lot. It's changed a lot since COVID, especially because we understand the phase outs that are going on. So I'm going to introduce my esteemed panel. And then in the same order that I introduce them, they will be able to present from this podium some prepared slides. So our first panelist that will present today is Suzanne Hagell, Chief of Greenhouse Gas Mitigation at the New York State Department of Environmental Conservation, Office of Climate Change. Her work portfolio is broad, but her primary responsibility is to identify opportunities for reducing net greenhouse gas emissions, including from all economic sectors of the state. Her previous experience and education focused on climate change adaptation, forest science, natural resource management, molecular genetics, and decision analysis. So let's welcome Suzanne. We're very fortunate to have her here today. Next we have Tim Hammond, Senior Director of Engineering at WaterFurnace. Tim is Vice President of Engineering for WaterFurnace and has spent most of his 20 years there learning about commercial HVAC and geothermal applications to innovate and expand commercial product solutions. He started his career in geothermal while working for a family-owned residential HVAC contractor and earning a mechanical journeyman's license, tradesman, I love it. He earned his mechanical engineering degree from Purdue, Fort Wayne University, and is a member of industry groups such as AHRI and ASHRAE. Let's hear it for Tim Hammond. Welcome, Tim. Next we have Adrian Perez. I recently got to know Adrian, sales engineer of Ecoforest, who has a passion that started in earning his energy degree. He knew that renewable energy, and especially ground source, was the field he wanted to dedicate himself to, so he is currently working at Ecoforest in the heat pump section, giving technical and commercial support in projects with ground and air source heat pumps. Welcome, Adrian. Thank you for being here. He was in Rochester last month at a similar symposium. Thank you. We'd like to welcome Jason Filler, who is a sales engineer at StarkTech. Jason Filler is a highly accomplished sales engineer with a focus on geothermal projects and energy-efficient solutions. He has an impressive track record of assisting design engineers in implementing heat pumps and heat recovery chiller systems, and has played a key role in the design and retrofit of multiple geothermal systems in P through 12 schools and universities. Welcome, Jason. I would like to now switch seats with Suzanne and let her share a few prepared slides. Oh, thank you. I didn't even notice.
Thank you. I'm a little shorter than you.
Thank you.
Thanks. I hope a lot of you are aware that we had a rule out for comment related to refrigerants. The public comment period closed a couple weeks ago. A lot of the stuff that I'm going to mention today is actually in the documents that we wrote to go along with that rules in New York State, something we call the Regulatory Impact Statement. And that's on our website. There's also an email address and stuff like that for contacting us if you have questions after today. That's what my job is to answer your questions and take feedback. And I'd love to hear more from folks even though the public comment period is closed. And I'll just do a quick promotion for some of my staff are going to the Binghamton ASHRAE meeting later this month to talk about this work as well. Please be nice to them. They're young, unlike me. I'm going to talk about two kind of contextual things around refrigerants as far as it comes to New York State, but also in a broader context. One is like greenhouse gas reduction requirements in the state, and the second is what's been happening with refrigerants globally. So in New York State, we had the Climate Leadership and Community Protection Act that was passed in 2019. We joined 15 other states that have legislation with statutory requirements or goals for reducing greenhouse gas emissions at that time. New York State's law is unique in that we didn't have a goal or a requirement, we had both. We had a requirement that state agencies achieve what we call the statewide greenhouse gas emission limits, which is what we call 40 by 30 or 85 by 50. So it's reduce emissions, that percentage compared to a 1990 baseline. We also had a goal in the climate law to achieve net zero emissions. And this is actually, in the law, it required DEC or my agency to issue a regulation establishing those limits, and that came out of our team as well, so I'm always happy to answer questions about that. One thing that's different about New York is that we were required to use a 20-year global warming potential. If you've worked with refrigerants, you've seen GWP. Most jurisdictions use a 100-year GWP that was in an international treaty I'm going to talk about next. But in New York State, we use or at least for achieving our requirements statewide under the climate law, we need to use a 20-year GWP. Fundamentally, it doesn't make a big difference with the design of regulations because we needed to achieve zero by 2050 either way. But I'm happy to answer more questions later, or feel free to email us if you have questions about this part of the law. Now, I know this is refrigerants are changing, but as you just mentioned, like they've always been changing. Like it's been an ongoing change back since the late 80s when it was discovered that a lot of the refrigerants were, well, not discovered, but there was an international agreement that a lot of those chemicals used as refrigerants were depleting the ozone layer. So there was a process that was started at that time, and what we're going through today is a continuation really of that process. So there was an international treaty, the Montreal Protocol. It led to a change in federal law in the US, which led to EPA issuing regulations. Some of you may know that EPA has been working on Rule 26 of the SNAP program, or the Significant New Alternatives Program. That means that they've issued 26 updates of that rule since the first rule in 1993. So every time they issue one of these SNAP rules, they change out. They say, you can't use this refrigerant in this end use anymore, you can use these refrigerants. And they keep doing that slowly over time, reducing the composition of ozone depleting substances in refrigerants. Now what happened in 2014, now I found paperwork from 1989 where in one of the meetings for the Montreal Protocol, they identified that they were switching from ODS to other greenhouse gases, and they knew that. So now in 2014, they got there and they decided, oh, we also want to reduce greenhouse gases too. That's also bad for everybody. So there was an amendment to that international treaty from the late 80s to also phase down the substitutes that they had introduced to replace ozone depleting substances, the refrigerants that we use today, which are hydrofluorocarbons. And the same process started where then there was going to be a change in how EPA did their regulations. They would start to phase out the HFCs. In the same process, they had been phasing out ozone depleting substances. But then there was a challenge in the courts brought on by chemical companies, not that they had an issue necessarily with the phase down, they had an issue as to who got to sell what when. They sued the EPA, there's a change in federal administration. What wasn't vacated by the courts was vacated by the federal administration. So EPA had started doing the HFC phase down in 2014. They worked, negotiated, got stuff on the books, and it was taken back. So a bunch of states got together, followed California's lead for a large part, and adopted rules to backstop what EPA had already started. That's the rule we have now, if you know Part 494 now. I know I get lots of questions about our chiller prohibition. That was in a rule from EPA from 2016. There's 16 states that have adopted this in regulation or legislation. But there was a switch because there is actually a lot of buy-in from chemical industry, from manufacturers to stay on the same trajectory as the rest of the world. They want access to the same markets. They don't want to enter in the global phase down late necessarily. So there was a bipartisan, and that's really rare in this country right now, bipartisan federal law called the AIM Act, which I hope a lot of you are aware of, which directed EPA to basically do what they had started already, start the phase down of HFCs. Ultimately, reducing HFC availability or supply, what they call consumption, 86% by 2036. So that's when the current refrigerants will not be available. And EPA is implementing that in a similar way that they did before. Instead of SNAP, there's something called technology transitions, and they just finished that rule. The first rule under that program at the end of last year. So just, I know a lot of you are already aware of this, but just to make sure we're all on the same page. So what does it do? What they did with ozone depleting potential, they're now doing with global warming potential and stepping down that metric over time. So the orange or brown color are countries like the US, and the blue is a slower, later phase down for countries like Mexico, for example. So where is EPA now? Let me see if I can use the pointer.
Yeah, you see it there?
Is it the red one?
That one right there.
Yeah, thanks. So EPA wrote a rule to come in so they can meet this step down here. Now, our European colleagues are further ahead because they didn't have the dust step in the mid-aughts. And they came in and they kind of were designed ahead of time. Now, when a new country enters Kigali, they enter where Kigali is. We didn't get a start at the top. We came in here in 2024 with a rule rather than having a rule that predated the first step down. So EPA has got what we expect and what they've sort of said, although it's hard to pin EPA down, is that, you know, a similar set of rules come in with a rule telling you what you can and can't use kind of ahead of these step downs so that the demand for HFCs is not greater than that dwindling supply, right? They want to switch out the refrigerants, or we all need to switch out the refrigerants so that we can meet this phase down. So technology transition rules, just like the previous SNAP rules, set prohibition dates for new equipment. So your new refrigerators, for example, switching maybe to isobutane, like a lot of refrigerators already are, so they can create a prohibition to make that a thing. They want to also list new substitutes as safety standards are developed, right, and as they're available on the market. So they've been issuing new decisions enabling new A2Ls, or the hydrofluorocarbons, or maybe propane, isobutane, CO2, ammonia in new uses. And all of their dates are based on multi-year negotiations, as well as long public comment periods and so forth. It's not the only thing EPA is doing. Just like with ozone depleting substances, there's other regulations about the international trade part, as well as about leaks, and a rule that's out that was closed for comment. They're still deliberating, should come out later this summer, on the use of reclaim, as well as managing leaks. So where does New York fit in? So I mentioned back in 2020 that we adopted a rule along with 16 other states. So there's the US Climate Alliance states. I was actually in a panel last week for a DOE meeting with California and Washington, and my colleagues and I realized that we've been meeting regularly for 7 years trying to figure out what we can do here. So we meet all the time. We meet bi-monthly now. We used to meet bi-weekly in the beginning. All these states joining together, figuring out what their role is, what can they do to help here. So we did adopt we wrote a model rule together, all these states adopted, prohibiting the highest GWP refrigerant. So the ones that EPA had already done the work for, essentially back in 2014, 2015. Our next step is like, what else do we need for New York? California's doing this too. California has a law, SB 1206, which establishes a final timeline. I mentioned this thing here. So this 2036 date, California legislators passed a law saying that California this year will release a report on how they're going to get, how they're going to get to here. So they have to write a report how to get to what we call GWP 10, or ultra low GWP. We're doing the same thing. So we've been doing for the past couple years, we've been doing concerted stakeholder work. We did a request for feedback back in 2022, trying to also do what California's doing. What does it mean to get to GWP 10 for different sectors? When are different sectors going to be ready? Obviously, there's CO2, and I mentioned isobutane and refrigerators. Now, there's some places where there's stuff on the market now, and there's other things that aren't. There aren't safety standards in the US like there are for Europe, for example, for propane for heat pumps. So what's that timeline gonna look like? So we want to expand our current rule, that's what we had in our proposal, to align with Kigali, add refrigerant and leak reporting so we can actually get the HFC emissions down, and we're also at the same time looking at incentives. Hopefully there'll be a new announcement soon about a new program that we're gonna have for supermarkets, for example. The biggest question we got, I got 253 comments on the rule. The biggest question I think in general is, why are we different from the US? How are we gonna be different from the rest of the US? And the effort that we have is to really align with EPA as much as possible, align with our other climate alliance states like California and Washington that I mentioned, but a lot of other states too. And what we wanted to do is both backstop what EPA is doing, because there's still always a risk of future litigation, for example, but we also want to make sure that component manufacturers, chemical companies, the suppliers of chemicals to the state of New York are getting a signal of where we need to be in 2036, so we don't have to worry about the supply as you hit EPA's dates, as you hit the dates in Kigali. And like I said, we're looking at what's ready now, for example, but we're also looking at maybe if something isn't ready now, is there the potential to use reclaimed refrigerant to buy that sector more time? Yep. That's me. Thank you.
Thank you, Suzanne. Let's invite Tim up. We're going to switch Suzanne over to Tim's. That'll be the easiest. And play musical chairs that way. While Tim is coming up, I read this report from Efecterra, if I'm saying that right, on the way over. Wow, they did a great job. I learned a lot doing that.
Yeah, and I know I don't have that mic, but I just want to thank, I saw Highmark outside. Highmark was one of the parties that contributed to that work group too. And if you want to see that report, please email us, happy to share. It's a report on natural refrigerants. Thank you.
Thank you. Go ahead, Tim.
All right. Good afternoon. I just wanted to give you a little bit of how a refrigerant change is impacting, companies like WaterFurnace. It's hard to believe that I was telling Jay earlier. I woke up and it's January 1. It's the clock's ticking. This is the last year for us to manufacture 410A. I've been with WaterFurnace for 20 years, and when I came into the business, R22 was on its way out, R410A was on its way in. And at the time, it was kind of like, okay, 15 years ago, it's like, what's going to change in the industry? It's like, nothing, and then everything changes, right? So there's definitely a lot of trade-offs as we move forward and we talk about, goals to get the GWP lower. We have to talk about the impact it has on other pieces, because in this discussion, we're talking about the GWP, the impact of the climate, but tomorrow I'll get on a call and the Department of Energy is talking about minimum efficiencies. And then there's another conversation about how do we make this safe? How do we keep the cost affordable? And as an OEM, that's just realistic, some of the challenges. So there's a lot of design trade-offs. And so I've been giving the refrigerant talks around the country for about 2 years now. And the audience changes quite a bit, and I get a lot of questions of what's an A2L. The next person is very knowledgeable on the subject, and they'll go in depth on the properties of refrigerant. So I thought I'd just start with what's an A2L. Do most of you know what an A2L refrigerant is? Can I get a show of hands? This audience is probably a little bit more knowledgeable than the rest. But so, normally in the 20 years I worked with 410A, nobody came up and asked me what an A1 refrigerant is, right? So just to give you a little bit of background, an A1 is a lower toxicity refrigerant, doesn't ignite under ASHRAE conditions. So as the industry the past few years, as we look at the GWP requirement, they came up with, traditionally we had A2 and A3s. And so we didn't have enough, acronyms, so we had to use A2L just to confuse everybody. But really what A2L is, it's the lower class of flammability. It's a subclass of the A2s. And so what they tried to do is look at and say, okay, it's technically flammable under laboratory conditions, but it has a low burn velocity. It's harder to ignite. So these are things the industry, I would say, took as the first steps. And I'll get into a little bit why the industry chose that, and we don't just jump to propane. There's, I know it's used in Europe, but there are some differences here in the U.S. But this, in general, the bullets up here are why we moved to A2Ls. And just kind of give you a reference point, it's about 1,000 times easier to ignite R290, which is propane, and that was a big factor in the U.S. So this is just a different way of looking at the flammability. You're seeing the heat of combustion on one side, you're looking at the burn velocity, and so here in the bottom are the A2L refrigerants. So you're going to hear R32, R454B. Those are really the two refrigerants that are emerging for A2L in the United States. And there's reasons why, if you look at R32, it's used in Europe, it's used in Asia. You'll see it more predominantly in VRF systems, mini splits, and then in most of, I'll say, water source heat pumps, geothermal, unitary ducted product, you're going to see a lot more R54B. A lot of that comes down to really preference on compression technology. I think when we talk about a refrigerant change, the thing we have to look for and be cautious of is the impact it has to the supply chain. I mean, we just lived, through COVID and supply chain where you couldn't get parts, and now, some of these manufacturers cover 10 years of warranty and service, and the design life per ASHRAE of a water source heat pump is 24 years. So I think we have to figure out how to balance lowering the GWP, but also if you bought a heat pump last year, 410A, you're expecting that unit to run for 24 years. We still need to be able to support expansion valves and replacing a compressor, replacing a heat exchanger. And so as we change the refrigerants, some of those design changes are more drastic than others. So I would say this is the first natural step for North America to make this change. And I'm not pro or against either one. This is just the reality of what we did in the United States, and more likely it's going to follow in Canada. And so here you can see on this chart, here's the A3s. And so, there's a big difference when it comes to flammability and how you have to treat it in the space. This is another way to look at it. I just like pictures and eye charts. So, but one of the things that we go through is, okay, we start with scrolls and rotaries are pretty traditional in comfort space or domestic water heating. And, the things that we take into account is, okay, we have to lower the GWP. That's goal number one, right? So there's this red flammability line that you see, that angled sloped line there is the flammability. So traditionally, the first step is stay within the given class of refrigerants, meaning if I go to 454B, it's pretty much like a 410A system. A lot of people don't realize you're using an A2L in some form every day today. So 50% of 410A has R32 in it. It's just now we're tweaking the blend, and that blend has now kicked up into a different classification. But the advantage of staying with that is there's not significant heat exchanger design. In the case of 454B, it's largely safety listing for the refrigerant. The compression technology hasn't changed. The expansion valves haven't changed. And so we accomplished the goal of lower GWP, but we get to kind of phase in. And then as Suzanne mentioned, we're going to continue to look for better opportunities for lower GWP. Now, some of those timelines are undefined, but you can see there's really, in that high pressure category, there aren't many options with a low GWP, so we have to move to the next category. When you move to the next category, I'll pick on 454C, for example, you may cut the GWP in half, but now you're looking at all redesign of heat exchangers, you're looking at compression technology changes, and so we have to look at what's the impact of the efficiency, because at the same time, DOE and others, 90.1 for commercial buildings is establishing minimum efficiency levels. So that's just another factor. There's cost and everything that goes into that. this is my favorite part. This is where everybody jumps up because there's nothing more fun than talking to a group of people about safety standards and building code. So this is just the reality of what we live through, and I think this is one of the biggest changes in this industry in my lifetime. I can remember growing up and hearing about Montreal Protocol, like, what is this stuff? But, you know, the industry's been working on ASHRAE 34. I gave you a little bit of intro what that is. That's just classifying refrigerants. So in the United States, you got to get an ASHRAE 34 before it can even really kind of get started. Then there's ASHRAE 15, which has traditionally been a commercial and industrial application. It's an application safety standard if you're not familiar with it. And one of the biggest changes to ASHRAE 15 when it came to having flammable refrigerants is the advent of 15.2. So there's now a code for residential systems. Historically, residential was included in 15. I would say I've never heard of it actually being applied in most of the country, but I think that's going to be a big change, especially for contractors, residential dealers that now have to deal with looking at effective dispersal volume, area calculations, how much charge am I putting in a room? That's a big change for the U.S. and how traditional product is applied, right? If you're putting a gas furnace in, you just connect it, right? It's not, you don't have to do any of this. And then what's kind of going on behind the scenes is this UL 60335-2-40, and it's a little bit of a mouthful. The U.S. has now somewhat harmonized with Europe on safety standards. It's the first start of trying to get some uniformity, but we still have our own deviation. So just to give you an example, we're agreeing to apply safety standards similar to Europe. Europe says the car's blue, and then we say, well, we agree, except for we're going to have a national deviation that says the car's red. That's just the reality of what happens. So what a lot of people don't realize is all of our safety standards are changing. The safety standard we have right now, which is UL 1995, has sunsetted. All new products follow this, and I know it's a pretty dry topic, but what's significant about it is you have to have ASHRAE 15, ASHRAE 34, and 2-40 in place before the building codes can reference it. So it's kind of the how and the what. So now the building codes are updated. That's what allows flammable refrigerants to be used in the space. Until this happens, you can't do it. And that's, I think, just looking ahead at future like A3s with propane, that this will have to get relived and re-vetted just to add the ability to put flammable substances or more flammable. So this is, again, I apologize for the eye charts, but this is just the reality of some of the safety impact that we're all going to deal with. And I'll try to just highlight a couple of them here. So the first thing is we look at charge limits. That's new. Most of us don't deal, especially in the residential space. Maybe if you're on VRF commercial, you deal with it. But we look at charge limits. Now we're going to look at area, volume of the space, leak detection, and then mitigation if you detect a leak. So you're going to start to see factory sensors. This is what we call an RDS. It's a refrigerant detection system that will now come in a lot of OEM equipment. And there was a mad dash by the whole industry to get technology, because this sensor's got to work for 24 years reliably in the space. And the technology did not exist up until literally the past year. So essentially what's going to happen is this sensor is now intelligent. It can self-calibrate. It's going to measure the LFL, so the lower flammability in the space. And then once it detects a leak, it's going to be able to shut the compressor down, turn on a fan, do stuff like that. And you know, there's a couple of different technologies out there. We use non-dispersive infrared, so we basically shoot an infrared. It's calibrated to the refrigerant. I show you this just that this is the reality of what manufacturers are dealing with. there's been a lot of people racing for sensor technology to get to production to support the timelines in the AIM Act. And so this is just a little bit of the impact it's having on our side, and just kind of showing you what we're going through as OEMs, that ultimately, you know, this adds cost, adds complexity, and especially as we go through supply chain, we're adding yet another chip, another board. So anyhow, just a little purview into our world and some of the stuff that's changing from a equipment manufacturer's point of view. So thank you.
Tim is now going to change places with Adrian. Let me get Tim his sign here.
Don't worry.
Oh, you got it? Good. Thank you. All right, take it away, Adrian. The clicker is right here.
Yeah, I think that.
Would you like to use a handheld instead?
Maybe yes.
Because you're so tall.
Okay. Here better. Okay. Basically, my name is Adrian, as Jay just introduced myself. I came from Europe, so a long trip, and basically I am going to tackle about, as just Tim said, challenges and opportunities for heat pump manufacturers with these changes that we are facing with refrigerants regulations. Okay, so I think that I can skip my presentation, but it was already done. I would like to introduce my company, because probably some of you know about Ecoforest, some of you probably not. We are a Spanish manufacturer, for that reason my accent, and we have started in North America in 2018. So we are still manufacturing in Europe, it's our main market, but 2018 we start developing our range here. It's fully certified, geothermal heat pumps, and we have sold across North America, and we have experience already in this country. I am glad that Tim also started with this. Basically, when we talk about new refrigerants, there are two things that manufacturers we need to take care about is GWP and flammability. About GWP, basically most of you you know what it is how harmful it is for the atmosphere, the refrigerant. Here is represented where we are, R410A, R407C, and what is coming, R32 and R444B. I think that all of us, we agree that are the refrigerant that North American industry is going to use. And I also mentioned R290 because as it was said, R290 is one refrigerant that is getting very, very popular in Europe. It's a natural refrigerant with a just global warming potential of just 3. So it's a big change if you compare with the other refrigerants that are represented on this graph. Okay, flammability was already well explained by Tim, so I think that I can avoid this part. Basically, I just want to mention one thing. When we talk about R290, there is a lot of controversy, okay, about the use of R290, as he just said. But R290 is going to be used as a refrigerant, okay? We are not burning R290. So this is, we need to make this clear because sometimes people is getting confused and there is sometimes some, I don't know how to explain, but frightening about the use of R290 when it's not, if you take the correct measures, there's gonna be any issue, okay? So if we talk about manufacturer's perspective, the problem is that there is a lot of different regulations all around the world, and in different applications. In this graph, okay, you cannot read it, but you can take from Danfoss, from the components manufacturer. There are different applications, different refrigerants, and you can see that some of them are available and they are allowed in some countries, some others not. So imagine for a manufacturer that we need to, we are selling in Europe, we are selling in North America, we are selling in Australia, that we need to face with different safety regulations in each country. So the same for the guys from WaterFurnace, that they are also selling on the opposite side of the world. So it's a mess. Okay, so it's true that the transition is to A2L refrigerants. R32 is very popular in Europe. A3 in Europe is as well very popular, especially in air-to-water systems, but our solutions are also in GEO that I'm going to explain you. So the reality is a complex situation for a manufacturer point of view. So talking about Europe, okay, basically they asked me to talk about Europe in this talk. I think that Europe is a little bit more flexible on the use of different refrigerants. R32 has been very popular in the last 10, 15 years, especially in air-to-air and air-to-water systems, basically because we have a lot strong presence of Asian manufacturers, that they are the ones that are promoting more R32 specifically. And it's true that R444B or other refrigerants like that are starting to be popular in Europe, but not so much. Talking about A3 refrigerants, basically it's R290, it's propane. It has been used in air-to-water systems since 2018, more or less, and with no issues at all. And also we have some products available with charge of 150 grams. In our case, with 150 grams, we have one product since 2018 on the market that is giving you around 22,000 BTUs, more or less. So this product is on the market since 2018. And also with a higher charge, we have new products. We can reach up to 55,000 BTUs, and we are using the evacuation system and the safety regulations that Tim explained. Okay, so as you can see, this is the casing that we are going to use also in North America for H2L refrigerants, and basically we have the encapsulated refrigerant circuit. In that refrigerant circuit, we incorporate that refrigerant sensor, leak detector. In case of a leakage, we are activating a fan, pretty similar to the one that you have in your computers, and we take out from the ducts that is represented in the left picture. Okay, so if you take the safety regulations that we are indicated in our manuals, you are not going to experience any issue, even in case of a leakage on the refrigerant circuit. Okay, so what are the challenges that we are facing? Okay, in terms of R&D, finally, my colleagues at R&D department, they need to think, read, and check all the regulations available. There are also limitations in terms of components availability. So finally, R410A has been on the market for so many years, but R290, R444B, they are pretty new in the use of domestic or light commercial heat pumps. So getting components sometimes can be also a challenge. And as I was mentioning, the different regulations in each country. In terms of operation, imagine R410A in Europe now, it gets postponed, the vanish of R410A until 2028. So we are able to manufacture R410A units. So now we are going to have R410A, R444B, and R290 units and components on our facility. So the number of suppliers, the number of components that we need to manage internally is a mess as well. So it's complicating a little bit the operations. And also from my position in sales and business development, I can see that there is some uncertainty on contractors, on users, and so there is, because they don't know if in 10 years the heat pump that they are using can be replaced or not, some of the components or so. So there is some uncertainty that we need to tackle as well. But there are not all bad things. There are also some good things regarding to this. The first thing is that we are releasing more efficient, more environmentally products, all the manufacturers. So I think that this is good, and also we are giving you more options. So I'm not saying that R290 or R444B is the right one. I think that there are different applications, and one or the other can be suitable for each case. And also in terms of market expansion. So finally, if I am here today is because our previous experience with R290, so it allows us to introduce ourselves and having these conversations. And finally, this is a networking experience where there are a lot of people from different sectors, policymakers, other manufacturers, suppliers, that we are cooperating on this change in the refrigerants. So thank you so much, and I hope that you enjoy the event.
Thank you, Adrian. Like it to invite you to change places with Jason over here. What a wonderful thing to get a perspective from a manufacturer that has gone through much of this in Europe already. Thank you. All right, Jason, take it away. Oh, here's your clicker, by the way.
Thank you.
Thank you.
I think I'm good. Well, I'm here to talk about refrigerants from sales rep, contractor's perspective. Here, we got a countdown called Countdown to A2L instead of Countdown to Y2K. It's countdown to the new refrigerants. And, we're really not that far away. 2025, when we look at our equipment lead times, is right around the corner. 38 weeks, we have some equipments, air handler, package equipment, has lead time of 30 to 35 weeks. So that puts us right up against the wall of this new refrigerant, 454B, A32, depending on the manufacturer. So when you're ordering your equipment, approving submittals, depending on your role, you got to look at your lead times at this point of the year on how fast equipment's going to be released, how fast it's going to be ordered, and really important is how quickly is it going to be installed and commissioned on the job site. So we're kind of getting into a weird spot right now is you might have equipment design as 410A on your job. Say you have 20 rooftop units or, bunch of heat pumps on your job, and they have long lead times. And say, the stuff gets released in June. It's not going to be delivered in time to have 410A. So now it's going to have 454B. How is that going to affect your end user? How's it going to affect your building? So this timeline, it's really not that far away. And we're facing this job after job. We have owners who don't want 454B. They still want 410A. And it's a tough conversation right now. Like, look, January 1st, 2025 is a lot closer than you think, and this manufacturing process is outside our control. Yeah, we had long lead times due to COVID. Those are mostly behind us now, but lead times are lead times, and we're up against this wall with the new refrigerant in 2025. So this countdown clock, it's a static clock, but it's ever present at my desk on how many weeks are to the end of the year and what we can deliver before the end of the year and how soon it can be installed. And even if it's a split system, EPA recently released a note saying 410A systems, split systems, must be commissioned, started up before the end of 2026. So you might think you might be getting away. Okay, you get your 454 condenser or your 410A condenser shipped before the end of the year and your air handler ships a couple months later. You got to make sure you have it installed before the end of 2026. So, really important deadlines to meet. So again, when you get your lead times from your equipment reps, from your contractors, keep in mind, we're only 38 weeks away from the start of the new year. So I love this coming from service, that's where I kind of started my career. Old service adage is pay me now or pay me later. And this could hold truer with the new refrigerants. As I mentioned, we had owners who said, I want it 410A, I don't want to move with the new refrigerant, do whatever it takes to get equipment shipped before the end of the year. And sounds great, they don't want to have two different kinds of refrigerant on the job site. They don't want to deal with the new refrigerants. But it goes deeper than that. Let's just look at R22, for example, right now. So when I started in this industry in 2012, R22 on average is about $30 a pound. $30 a pound. And I checked the price just the other day, and it's up to $70 a pound for R22. There's still systems out there with R22. So 410A today is $14 a pound. How much do you think that's going to be in 12 years? It could be up to $70 a pound. So again, you're going to pay now for the 410A, or you're going to pay later when you have a refrigerant leak or you got to do a repair, you're going to pay an exponential cost for that refrigerant. We don't know what it's going to be, but we know in 2036, we're going to have an 85% reduction in 410A production. So that's things you have to factor in. Yeah, the 454B equipment's going to be slightly more expensive due to the refrigerants and the safety devices that are required on it. But again, look at the cost of refrigerant, look down the road and what you think that 410A is going to cost. Another thing to consider is, again, the environmental considerations, pay me now, pay me later. 410A, you know, not so great now, it's gonna hurt the environment now. 454B, you know, we all wanna be good stewards of the environment, right? 454B has 78% less GWP than 410A. So if one of your corporate goals is to lower your carbon footprint, why wouldn't you push ahead and maybe wait for that equipment in 2025 for 454B to lower your carbon footprint? So that's one thing to consider is look at the environmental impact. And you know, even 410A, if you have a leak, how does that impact the environment? So all these little things to consider, you know, again, it's not a straight cost thing that, okay, 410A equipment's cheaper now and 454B is more expensive, so I want the cheaper stuff now. It's gonna end up costing more in the long run. And as I was doing research for this presentation, I found an interesting story about there's actually already a black market for high GWP refrigerants, which blows my mind that this exists. So on March 4th, so almost a month ago, a 58-year-old man became the first person to be arrested for illegally smuggling greenhouse gases from Mexico. I don't know how they figured out he was smuggling greenhouse gases, but he was smuggling them in the back of his truck under tarp and tools. He sold them on Facebook Marketplace. So I assume he maybe selling R22, but now he faces a fine up to $250,000 and 20 years in jail. So imagine that. We're just getting into this phase out, or phase down, I should say, and there's already people smuggling refrigerants over from Mexico. So it's pretty wild what's already going on. So imagine, again, what's going to happen with 410A in 2036 when we're down to 85% reduction in that. So Tim talked a little bit about ASHRAE 15, so I won't go too in depth on this. The big thing I want to take away from ASHRAE 15 is the effective dispersal volume charge, or the EDVC limit. So there's a big change going from 410A, a class 1 refrigerant, to 454B or R32, a class 2, and how the dispersal rate is calculated. So the class 2, the volume is based on your occupied and unoccupied spaces. And they base the dispersal rate, the formula on, really the big change is class 1 is based on your refrigerant concentration limit, and then class 2 is based on your lower flammability limit. So that really changes how much volume you have to work with on your refrigerant leak. So on the class 2, you have less of a volume to be able to, for that refrigerant to disperse. So that changes a lot of your designs on how much refrigerant can leak out. And we have a couple examples going forward that I'll show you. And Tim had touched on, you know, requiring refrigerant detection systems on your equipment. There's going to be required mitigation actions, mechanical ventilation, and two big things I want to point out is with anything with A2L refrigerants, there's no open flame producing devices. So think makeup air units with direct fire burners. Now you can't have a DX coil on those pieces of equipment. So things like that, and then unclassified electronic devices. So again, they can set up a spark, and you've got a flame inside your ductwork. So a big thing during COVID was bipolarization. A lot of those things were not UL listed. So things to pay attention to as you're designing or installing systems into your buildings. Another note on ASHRAE 15, so your refrigerant quantity on your leakage rate, it's based on any one independent circuit. So if you have two circuits, you don't have to calculate your leakage rate on both circuits. It's just on one circuit. So maybe when you're looking at equipment now, look for two-stage dual circuit equipment because that will lower your volume rate that you need. A big thing is with ASHRAE 15, air circulation when a refrigerant monitor detects a refrigerant leak must be initiated. And this is going to be done mostly for the manufacturer. They have a preset airflow that they're going to set off if they detect a refrigerant leak. Again, must be integral to the equipment, and It's for ducted systems with a charge greater of 4 pounds. Again, and if it's activated, pretty much going to open up all your dampers, activate all your fans, and just dilute the air and activate the refrigerant shutoff valves to prevent any further leak. And this is all set off requirements in ASHRAE 15 that has been recently released in 7.6. So if you guys have any questions on this, you know, ASHRAE 15 is pretty long, standard. You can skip over, go 7.6, which goes over all the new A2L standards. But those are kind of the highlights. So here's an example of a water source VRF system. This is a geothermal. All right, this is a geothermal VRF system. So it's kind of a goofy layout here. I had to put on the slide. Right. That's all right. All right, so we have the first floor here, the second floor there, third and fourth. So this is a 410A system. So this is a traditional way of laying out a VR system, 410A system. So we're able to maximize the heat recovery system by tying the first, second floor system into the same refrigerant transfer box here. And then we have another transfer box between the third and fourth floor here. So we're able to transfer the heat between the two floors here, and everything goes back to our water source condensers in the basement. And this gives us the maximum heat recovery. We have our just two condensers here, and then all our indoor units are essentially connected. And with 410A, this is fine because we have a higher dispersal rate than the A2Ls. So in this system, this is a 32-ton system and about 92 pounds of 410A. So when we're looking at a VRS system, you got to look at your smallest occupied room for your refrigerant leak rate. So now with the A2L, since we're dealing with a higher leak rate, it looks something like this. So now we had to break it out. Instead of 2 condensers, we have 7 condensers here. And you can see on the second floor here, we broke out into separate condensers here. And this is just to limit our charge on the smallest occupied space. So unfortunately, we lose the heat recovery on the indoor units, but we still have heat recovery because of geothermal, so we have the heat recovery inside the ground, but indoors, it's a little less efficient. So these are some of the challenges we'll have going forward. And our charge will actually increases going to this up to 108 pounds. So, you know, you gotta pay closer attention when you're designing your refrigerant systems now because of that effective dispersal rate. And some other ways around it, again, you wanna increase your volume so you can duct two rooms together. I'm gonna try to go a little bit quicker here. You can use an open plenum in your roof, in your ceiling rather, and open up some wall spaces. So you can do, you know, false ceilings, air transfer ducts, door undercuts, transfer grills, anything to increase your room volume will help you. And the last thing I'll have is we just recently did a chiller retrofit of a 410A chiller. This was a split chiller, so we had the condenser outside and the evaporator inside here in the mechanical room. And this is a 410A system. Inside the mechanical room, they didn't have any ventilation in case of refrigerant leak. So when we went to go to replace this, we couldn't replace it with a 454B piece of equipment because they had no mitigation factor inside the mechanical room. So we ended up just replacing it with a straight package air-cooled chiller and running the water pipe outdoors and glycol the whole system. So that was one of the challenges we have with switching from 454 to 410A, or excuse me, 410A to 454. And this is my last slide here. And again, we're talking about 454B and the A2Ls being flammable. Again, we got to think about our placement of our equipment now. So we got an air-cooled chiller here, and it has relief valves for refrigerant. So we can't put this next to an ignition source. So we can't put this next to a gas meter, anything where it might set off a flame. So you got to keep your chillers or anything with any kind of refrigerant relief, you know, at least 4 feet away from any kind of ignition source. So again, something new to consider when you're retrofitting your equipment. So just these little nuances to think about on your projects. That's all I got. Thank you.
Jason, thank you so much. I was told by Chris, I'll switch it over to here so you can, I was told by Chris that we could go over a little bit if we need to, so I'm going to, as the moderator, authorize an additional 5 minutes on the hour for us to do this, and I'm going to just start it off while Chris looks for another question. I'd like to ask Suzanne a question. What exactly do you believe will happen for people that want to buy refrigerant as of 410A as of January 1, 2025? Will they notice a difference, or is it going to be a whole new world in your opinion?
So we don't have our current regulation, and then there's EPA's regulations, and those are
Yep.
different.
Right.
And our regulation that we just did, the comment period was just a proposal, hasn't been adopted.
You got it.
And I'm going to give more caveats. Every end use is different. So it depends if you're talking about a supermarket rack, or are you talking about a certain kind of, it could be a heat pump chiller, it could be a heat pump, a residential heat, and it really depends on the end use.
So nothing, it'll be kind of, well, it's here, not a lot has really changed, but the manufacturers notice a difference right away because you have to have everything done by that time, right? I mean, you can't manufacture any more 410A equipment as of 25.
Yeah, that's right. We cannot manufacture. VRF has till January 1, 2026.
Got it.
But heat pumps, chillers, I mean, right now in the state of New York, we're shipping 454B because they adopted SNAP 20, I believe, which was ahead of the AIM Act. But I think on the refrigerant side, what I wonder and anticipate is, you know, it's based, the phase down is based on million metric ton CO2 equivalent. So companies like Chemours, Honeywell, you know, they're doing calculations and they're saying, okay, if I drop 1 pound of 404A, I can produce 4 pounds more of 410A. Until, you know, I do think there are states like California that are looking at saying, okay, past such and such date, no more virgin refrigerant on replacement retrofit. You're going to have to go to a reclaim only option, which will drive the price and I think move people faster into new adoption.
Thank you. Who has questions? Right here, I see Chad first, and one here and one here. All right, thank you.
Hi, it's Chad from GeoSmart. Just a quick question about how much time you think we'll have after that sunset in January for our 410 equipment that's already been manufactured to flow through the distribution channels.
It's 1 year to install. One year to install for systems, yes. I believe, correct me if I'm wrong, condensers, you get 3 years.
Not to speak for EPA, but in EPA's rule that they finalize, so systems, something you install on site, you have 1 year to install. For VRFs and heat pumps, other equipment, there's no extra year. There's a prohibition date is install. For package stuff, there's 3 years to sell through. So you can manufacture, and then you have another 3 years in EPA's rule to sell through.
Go ahead, thank you, sir.
Sure, so I had a question for Suzanne as well, clarification on.
Can you share
sorry,
your name?
a little closer, is that better? Question for Suzanne. So for clarification on could you clarify a little bit on the timeline for the proposed regulation for part 494, particularly in relation to like single family residential air source and ground source units? What exactly the timeline that's proposed for banning 410A, and the second part of that question is what's the timeline for that regulation being definitively released? Because there's a lot of questions in the market of like, how do we know what to order and what to build?
Yeah, that's a great questions. Well, one thing we talk about R32, that's HFC 32, hydrofluorocarbon 32, that's in 410A. So 410A is a blend of HFC 32 and something with a higher GWP, and so that's why they're going to R30. They're going to HFC 32, but it's still subject to the same phase down. So it's no matter what, with implementing the AMAC, there's going to be a timeline if it's not at the state level, at the federal level. So what we did in the proposal, which I hope a lot of you read and commented on, is adopt what EPA just finalized for the near term for that sector, which they call residential and light commercial air conditioning and heat pumps. And then there's a little bit of a different date for VRFs. But so in the near term, line up with EPA. But what we proposed was an interim before you get all the way down and you have to get to ultra low GWP like R290, that maybe we could use reclaim. You know, maybe manufacturers could put reclaim out there, especially for packaged equipment. EPA has a similar proposal for some packaged equipment, some systems, both for new and also for servicing. But we'll see where they land later this year on that. So that a way to buy more time is to use recovered refrigerant, essentially. But we'll see on the final adoption. Still reviewing comments right now. I can't tell you. I don't want to give an EPA. I can't tell you when I'm going to finalize. But there's a lot to think about, and we got a lot of great comments. It's every sector, and it's not just refrigerants. It's foams, it's aerosol propellants, it's solvents. So we're thinking about all the comments that we got, and there's a lot of really great feedback that we got. And, you know, I'd love to hear more. You know, we have the public comment record we have, but I want to adopt it as soon as possible so people know ahead of time. If it gets pushed, then we'll have to push the dates because we can't shorten the amount of time that we give people, lead time. So not a great answer, sorry.
Thank you, Suzanne. I think we have a question over here from Robert, and we probably have time for one more after that, depending on this, the depth of this question and answer. Go ahead, Robert.
Jason, you mentioned that part of the, I believe, the EPA regulation that these 410 systems had to be commissioned and installed by the beginning of 2026. Does that include any other, is that all A3s or of the GWP, same classification? Are there any other refrigerations included with that?
As far as I know, it's just the 410A, just the ones being phased down.
Okay, and is that VRFs, you know, package air handler units? What systems is that
It's
include?
the package. The VRF, they have another year.
Another year after that?
The VRF has their phase down is 2026, so I believe they have probably another year for that.
Okay, so the package units are end of 2026?
So the package and then your regular split condensers, air handler and regular condenser would be end of 2026.
I just want to say that, so EPA did put an update giving an extra year for VRFs. It was a question, I think, whether or not VRFs would have the extra year as well. So I think
Okay.
that's been decided that they were going to get, but it was a later update. But it's on EPA's
Okay,
website
thanks.
too.
Thank you, Chris. Robert in the very back has a question, and I think we'll probably be done. Thank you for coming in with the great final question of the day, Robert. Robert's with the Union of Pipe Fitters, representing 400,000 U.S. families. Thank you.
Thanks, Jay. Rob Vilches with the UA. So I'd hate to end this on a deeper conversation, but something we all should think about. It was mentioned there's regulations in play that are going to require us to use reclaimed refrigerant as opposed to virgin refrigerant for 410A systems, right? We're still installing those 410A systems. The industry is going to face a problem, not next year, but 2-3 years from now. If you look at the current reclaim rate for the HVAC industry, it's not high enough to support those initiatives. So the industry as a whole has to make a change to where we are recovering more refrigerant and sending it to reclaimers. Otherwise, that stuff will not go well for the end users. We'll have a lot of angry end users and contractors that are going to end up taking the brunt of those complaints. Because systems are going to be down for a long period of time just for that one reason.
That is, does anybody have a comment to add to what Robert just shared?
I would agree with him. I think the number is 10%. Yeah, I mean, it's significantly low, and I know at least, and we were in a meeting last week, and we told several of our customers that exact same thing. It's gonna have to, one way to help this whole situation is to increase that 10%. I mean, that's, so, yeah.
Well, thank you, everybody. I just want to say this is a tough question. I think we can fit one more in, Chris, unless I would. Thank you. This is
Yeah.
I remember hearing you in an earlier session. Thank you for speaking up. One more,
Thank you.
please.
Yes, I would like to ask, can somebody speak to the fact that in our our not-for-profit 7-family low-income unit, I was told that you couldn't put refrigerants, like the Samsung makes a unit that has the heads that operates off of the refrigerants.
Yeah, wall hung mini split.
Can y'all speak to that? Because I think that's better than running the ducts and all that stuff through the basement. You lose a lot of energy, but what about the safety? Can you speak to that? Thank you.
Go ahead, anybody.
I'm not sure. Are you asking in the future, can you continue to do mini splits and VRF?
You said more than 5 units. If you have a building that has more than 5 units, that you can't use refrigerants with a residential. I don't know if that's true, but if you could tell us, that would be nice.
I would say when we get to, so I guess for some clarity, right now, you can't use A3s in North America. In comfort applications, it's like 6 ounces, which is basically you can't use it. So the only place you can use A3s is essentially in a refrigerator or in a freezer. But I would guess I would say it like this. There's going to be more restrictions on those type of systems in 2026, and I think they'll have to change how they approach it. So, for example, and I'm not a VRF expert, but I think today if they do a 10 indoor head to a common outdoor, they're going to have restrictions based on the space and the number of heads. So they may split that up, and that may become 2 or 3 different outdoor systems to reduce the overall charge to accommodate what Jason was saying, ASHRAE 15. So it won't outlaw it, but it will change the design approach, which then could then make it cost prohibitive and change into other solutions. Well, it's going to be the same issue. Well, technically a ground source would probably be worse because it's indoors. So with an air source, you get to stick the condensing unit outdoors, so they can put safety valves in and they can try to isolate sections of and get to what we call releasable charge with enhanced tightness. But if the geothermal compressor section, if it's indoor, you just took all the charge, and now you have to accommodate the entire system charge in the space. So I think it's going to be more prohibitive to do a ground source system of that nature. Well, again, it's not illegal. It's just, it'll just depend.
It's being regulated out of existence. We have to just work within the laws. Let's give our panelists a round of applause, and thank you everybody for staying here. I'm going to stay here until everybody clears out, and our panelists, if they choose to, can answer some questions, of course.